Hello and welcome. This is Ismail again, and in this video I'm going to be showing you some of the practical ways of following the data processing steps that we covered in the last video. So before we start anything, especially when it comes to data processing in any form, by now we know that we should probably load dplyr into our environment. Let's also add tidyr, and we're just going to go ahead and load those because they are pretty common for use when dealing with data in R. We can just get rid of the warning. Now, for the sake of this video, I'm gonna be using the Star Wars dataset. So you might be familiar with this dataset. We did use it in some of the earlier sections. So you can go ahead and just view the dataset like so to get an idea of it, right? We have the name column, height, mass, and if you want, you could actually also just pull it up in the viewer, in the data viewer, using the view function. And there we go, we get a larger view of the data. And so we have a bunch of variables, a bunch of features or columns, if you will. We have skin color, we have eye color. You can organize. We have the sex, we have the gender, we have the homeland or the home world, species, the films the character showed up in, the height, the mass, etc. So we have a lot of data here, and you can actually filter, based on each one. You can view the distribution. Right here we can see that there does seem to be an outlier here. Hair color, we can just filter for white. I have my caps lock on. Just filter for white, and we see only the white ones, and then within that we want those that have fair skin, and so on and so forth. We know how to do this using code in our notebook, as we've done so many times before using dplyr, right? But that's just how to quickly explore the data. Now, there is a very useful function or a very useful package in R called skimr, and let's go ahead and load that. We have to install it. So install packages skimr. Let's just let that install. And this package allows you to get a very quick snapshot into your data. A lot of the statistics and the stuff that we were looking at, the distributions and that kind of stuff, it gives it all to you. The different variables that exist, the types of variables there are, how many missing values there are in each variable, that kind of stuff. So it summarizes for you the data. And so in order to use that, so let's load skimr, and the function we want to use is called skim. So let's skim the Star Wars data set, and there we go. We get this very nice view of the data set. So we get a data summary. It gives us the name of the data set, the number of rows. So we have 87 rows, the number of columns, 14. The different types of columns we have. So we have 8 character columns. So we're going to need to do some vectorization on those, right? We need to convert those into numeric variables. We do have 3 numeric columns, and then we have 3 that contain lists. And that's something we're not going to be covering in this course, but keep in mind that you can have lists or vectors within columns. But that's too advanced for us at this point. And so then you can see the different character variables. So we have name, hair color, skin color, eye color, sex, gender, home world, species, and the number of missing variables or the missing values for each variable, and the completeness rate. So what percentage of those values are not missing. So this is 94%, which is pretty high, right? But it's not 100%. These are 100% not missing, 100% complete. This is 95. So this is pretty low. 88% or 88.5% of the home world variable is missing. So that's definitely something we need to take care of. And then we have here the numeric variables, and we can see the distribution, their means. So you can see that the means are all over the place. This one has a mean that's almost twice as much as this one. The standard deviation is also all over the place. So this should ideally be normalized or standardized, which we're going to do as well. So just to make it easier, let us actually select some columns to work with, okay? And just assume that the data set consists of just those columns. So let's select height, mass, and gender, okay? So we have height, mass, and gender, and we can print that out. So let's just work with these 3 columns, okay? Forget all the other columns just to keep everything simple. And then you can go back and you can do what we're doing, all the pre-processing we're doing on the whole data set if you want, okay? So the first thing, remember, before anything else, we need to sample our data. We need to split it, into training and testing data. And we could do this on our own using the square bracket. So we could take data and then just square bracket and then randomly generate some numbers and then use that to split the data and that kind of stuff. And that's completely doable, but it's unnecessary. We have a package called rsample from the Tidy Models ecosystem, and we should actually install. Let's go ahead and install rsample first. So that's installing. Once it's installed, we're going to be using a function within rsample called initial_split. So let's go ahead and start writing this. So let's create a variable called data split, which will contain the split. So, okay, there we go. It's downloaded and it's loaded. So data split, let's just call the variable data split, and we create an initial split. And initial split is a function from rsample that we just loaded into our environment. And what are we initially splitting? The data that we have from up here, okay? Now, that creates, a data split object. And within it, the training data, and to access it, we can just use the training function, again, from rsample. So training data split, and we have the test data, and then we use a testing function, data split. Okay, so we're taking our data, we're creating a data split object from it, and then we're extracting the training data from it and the testing data. And so if we run this, okay, and we pull up our environment from down here, you can see that we have now a data test data set and a data train data set. So remember how we had 87 rows for data? Now we have 21 rows for the testing data and 66 for the training data. So if we were to actually test that out, 21 divided by 87, that is in fact like 24%, right? And then 66 divided by 67 is about 75%. So they used a split of 75 to 25. I said in my presentation 80 to 20 or 7 to 30 would be good. So this is right there in the middle. So now we're going to ignore data test. We're not going to use data test at all. And we're going to work on data train. That's what we're going to use for all our work. And at the very end, we can validate using data test. So that's the whole point of this exercise, right? You always need to do this at the beginning of your work and then just stick with using data train, okay? Now that we have a split, we can start feature engineering. So feature engineering, remember, means creating new features or variables. Now, we have enough knowledge on this data set to understand that, this is height and mass and gender. Something that a lot of you might know about is BMI, right? And BMI is a formula of mass and height. So we can actually create, let's say, for example, a BMI column. And that column would be created using existing columns or existing features, but it would be a new feature altogether. And it might give us an edge when training our models, right? It might cause our model to become more accurate. And so it might provide useful. So let's go ahead and actually add a BMI column. Let's take data train, right? We're not using data test. Let's pipe it into the mutate verb from deploy_r. And then let's create the BMI variable. And that would be mass divided by height squared. Now, again, some of you out there might know this stuff more than me, of the BMI and the calculations for and that kind of stuff. So this might not be that accurate. It doesn't matter, as long as, we're creating a new feature. And let's go ahead and run this. And there we go. We have this new feature, this new column, and that's how it looks. And we want to save this into data train. So that now, if we were to run this, we have updated data train to contain this new feature, this new column. So we've actually just engineered a feature. This is an example of feature engineering. Now, what about missing variables or missing values? You can see here there's a missing one here. To get a better idea of which ones contain missing values, we can use skim again, this time on our smaller data set. And we can see that actually all of them contain missing values. So, gender has 4 missing values, height has 5, and mass and BMI have quite a lot. They're only 96.2% complete. Another way to check missing values would be using the any function. So any is NA data train. So we're running is NA on data train, and you were using any to return true if there's even one NA. Okay, so let's go ahead and run this. And there we go, we get true, right? So this proves to us that there is at least one missing value somewhere in the data set. So this gives us whether or not there is any missing values in the whole data set. In order to check if there are in any particular column, we can use call sums is NA data train. Now remember, if something's true, it's represented with a 1. If it's false, it's represented with a 0. So if the sums of all the columns are 0, that means there are no missing value. However, if it's greater than 0, like let's say it's 3, that means there are 3 missing values for that particular column. So here we can see that, there are 5 for height, 21 for mass, 4 for gender, and 21 for BMI. Okay, so now depending on the variable, it makes sense to approach it in different ways. So since 5 and 4 are pretty low, right? They're pretty complete, 92.4%, almost 94%. We don't really have to bother too much with these missing values. We can just get rid of them. We can just drop the rows completely, pretend that they don't exist at all. And so let's do that. Let's take data train, and we use the tidyr function called drop NA, and we specify which NAs to drop, like from which variables. So we want to drop from height and gender. Now, if we run this, see, initially we had 66 rows in our training data set, and now we have 58 rows because we dropped the missing height and gender columns. Now, let's continue and let's fix the mass and the BMI missing values, and let's fill them in with the average of those columns. So let's remember, it's called imputation. So mutate, okay, mass, we want to fill the missing values of it, and we can go ahead and open this up here. So mass, let's say this here, this. We want to fill them with the average of the whole mass column. But we want to only do that obviously if it's missing. So we have to use if else. So if else is NA mass, then we want to fill it with the mean of the mass, and we do remove NA. Otherwise we fill it with mass. So this might look complicated. It's not. What we're using here is if else, and it has 3 parts to it. So this is the part where we check it, right? This is the thing to check. If this is true, the first one is used. If it's not true, the third one here is used, like the second one. So this is the condition, and these are the the true and the false results. So we're saying if that particular row or that particular value of mass is missing, then take the average of mass and calculate the average by removing any missing values. Okay, so that's important there. Otherwise, just keep it the same. So if we run this, and let's just run this right into here, as you can see now we have no missing values at all for mass. And instead they're replaced by the mean of the mass column. Now let's do the exact same thing, but this time for the BMI. So if there's a missing value in BMI, we take the average of the BMI. Otherwise we take, the BMI. This should take care of the rest of the missing values. So let's save this in data training. Let's call it imputed. And if we actually, let's skim data training imputed, and we can see that they're all 100% complete. 100% complete. So that's how we deal with missing values or incomplete data. So let's just, to make it easy for you, let's call this feature engineering. And then here we get into missing values, feature engineering, missing values. And then now let's talk about encoding categorical data. Categorical data. So let's work with the iris data set for this. Remember the iris data set, we have 3 different species, and we can skim iris to see that. Species, there are 3 unique values, setosa, versicolor, and virginica, and they each have 50 values, 50 occurrences. Now, we want to replace, so this data set is almost all numeric. We just have this column that we need to make numeric as well. So we need to encode it, right? We need to vectorize it. And we can see from skimr that this is actually a factor. So remember how factors are actually represented by integers. We can actually just take iris and we can mutate and convert the factor into, or coerce it into, an integer. And there we go. So the first species is represented as a 1, the second species as a 2, and then the third species as a 3. So this is one form of encoding categorical data. Definitely, right? This is definitely a way to do it. One problem with this is that you are basically giving this variable an order, which is going to be a problem because there is no real order to this species. It's just completely random. So you don't want your model to assume there to be any numerical order. And so to prevent that, you can do something called one-hot encoding, where you replace that variable with other variables.